last one modified is this text file. So you can open it with Excel, or you can go into Excel and open file open and navigate to that text file. And we'll see that we get a very, very simple Excel file here. Okay? So I'm going to try to go slowly through here. Sometimes I get excited when I get to deal with statistics and effects. So if I go too fast, slow me down. And the first thing I'm going to try to do is just organize this data, the sheet, a little bit so that everybody can see it and understand it really clearly. Okay? So the first thing I'm going to do is just try to organize our labels up here. Okay? So what you can do is just double click your column separators and see how it makes it the same width, or it makes it as wide as the last word in it. And so what I'll do is then highlight that, and then I'll center it. Center. So all I did was just make sure that the columns were centered. I like it because I'm kind of a simpleton, and my brain works really well when things are very organized and clear. So I think that helps me to just start off on the right foot. And the way that we're looking at it is here's our subject numbers. I grabbed subject 48, 47, 45, 44, 43, 42, 41, 39, 38, 37. Okay? And so the first thing, in case I forget later, I like to type in here and just go subject number. I also like to make it bold. We can put a little underscore line on it. So now it reads a little bit easier. Okay? And so what we have here is the measurement of the amplitude. And in our titles, in columns A and B, we have our two bins, 87 and 88. And to help us out, it tells us that it's at P3 for each of them. It also tells us what the condition name is. So 87 is times when they said an old item was recognized with a low confidence rating of 4. And bin 88 was when they had an old item recognized with a high confidence rating of 5, that you might consider recollection kinds of remembering. So that to me just helps me to remember stuff, no pun intended. Is everybody on board with kind of structurally how this is organized? Okay, so how many of you guys had a lot of fun working in SPSS in your stats classes? Nobody?
Sorry, say that?
How many of you guys had a lot of fun working in SPSS in your stat classes? Yeah, it's not always a big party, is it? This is going to be real simple because I'm going to show you guys how to do some basic t-tests in Excel. Okay? So my recommendation is to write down some of these steps so that you don't forget them, because you're going to need to do them to report your statistical findings, perhaps even on the test on Wednesday. Okay? Ooh. Okay, so and I'll probably start and I'll delete that too. So, what we need to do is we need to know, well, first of all, let's type in some things that we like to know. Right? Let's say, what's the first thing you want to know about conditions? You want to know the average, right? What's the mean? Okay, so let's get the mean. So I'm going to type in the average. Do you guys like the word average or mean? Let's just do average. Does that sound better? Average. Okay, what else do we need to know? Standard deviation? Yeah? Okay, so we're going to go SD for standard deviation. And we also need to know maybe the standard error. Okay, so let's type SE. Okay. So let's just start with our average. That's easy enough. The way that you do that in Excel is we're going to write some formulas. I'm going to basically show you the really easy way to write the formulas to do your stats. You do equals. When you type in equals, it automatically tells Excel to expect a formula. Okay? And since we're looking for the average, it's real simple. You just type equals average. And notice that it brings up these little options of an actual formula. So you're going to start by adding a parentheses. Okay, so you're going to open up a parentheses, and it's going to ask you, what do you want to take the average of? Here you are, the king of your castle, the queen of your domain. You're telling your servants, give me the average. Bring me back the average. Go fetch me the average errand boy. Right? And it says, sure, what do you want me to get you the average of? And you're going to tell it all of this. And really simply, all you have to do is just highlight it. Just like that. And then you close the parentheses. And that's it. Press enter. Bam. Now one thing I like to do is I'll insert a row. That way I have a little bit of spacing beneath here. Okay? So that's our average. Okay? Now, if we want to know the standard deviation, it's really simple. You just write equals, and it's abbreviated as ST for standard, and then DEV. Standard dev. Open parentheses, and you grab the same group, close parentheses. That tells you our standard deviation. Now the calculation for our standard error is going to be a little bit more complicated because it has to do with the sample size too, right? I know you guys might be a little rusty on your equations. You guys don't walk around armed with them memorized? No? Okay. That's okay.
Out of all the things in psychology, statistics is the one that I'm like, I like it, I don't think I like statistics.
So, the way that we'll do standard error is it is basically the equals basically the standard deviation divided by,
Degree of freedom.
what's that?
Degree of freedom.
Well, not quite the degree of freedom, but it's basically divided by the count of our sample size. So we'll just do that. But for now, you don't have to worry about it too much. I just want to show you. And now we want that. Now
Now, divided by the count of what? Yeah, it's your average.
it's just your so.
Oh, okay.
So if you count up, so I should say, this is your sample, right? There's 10. So the way that you get that number 10 is you tell Excel to count how many are in this grouping. So it's just the same way of, you can type in,
Okay.
Makes sense? All right. So, if you highlight that and grab the, remember our little corner that we dragged down earlier in the class? Let's drag it to the left. And it will do the exact same thing for column A. We can verify that by double clicking in column A. And it tells us that it's equal to the average of our column here. Pretty nifty. Isn't that easy? Don't you wish you would have known that in stats, huh? Okay, so let's do the actual t-test now. So what I want to know is, does the average of this condition differ systematically from the average of this condition, right? Is the ERP for when we have high confidence recollection different from the ERP from low confidence recognition at the left parietal site during the time of the LPC in a significant way? So what we need to do is run a simple t-test. Do you guys remember what that is? Okay. I'm going to show you another really easy way to do it. It's going to make you want to throw SPSS out the window. It's really nifty. It's really easy. Okay. So what we're going to do, let's go. There's a couple ways to do it. Let me try something first. Do data. If you guys go to your data tab, is there an option for data analysis? Yes or no? See how I have data analysis over here? So we go to data, which is there. Do you guys have that or not?
Okay.
Huh?
No.
Okay, I'm going to show you how to add that. Okay? Once you add it once, you won't have to add it again. Okay? So you go to File, and you'll go to, I think it's Options. Yeah. So in Options, you're going to select Add-ins. Okay. So you have File, Options, and now we're going to come to Add-ins. Okay. Now, I added in the Analysis tool. Okay, so that should be somewhere in your list. Just grab Analysis Tool Pack and whatever button there is for Go or OK or whatever, you can hit that. Okay? So you go File, Options, Add-ins, and you're going to do your Analysis Tool Pack. Just do the regular one. You don't need the one that has VBA. So just do Analysis Tool Pack, and then just hit OK. Has anyone not done that? Is it not?
Like an option on my file.
You don't have. It doesn't even give you options, really. Let's take a look.
That's the right file. Just analysis to the pack.
It's once we find it, we're gonna be like, oh yeah, we're gonna be like, yeah, that we should have done that. Does anybody have a Mac that has access to figure out how to do that from Mac? Does anybody else have trouble adding that? Okay, so basically Mac people.
No. Oh, I'm a PC.
Can the Mac people Google it real quick and just say add analysis tool pack in Excel, and it should be there. So which computer? Do you have Excel on? Let's do this one so it works when you take it.
It doesn't have it. Does it make them more work? Excel 2011, there was that, it doesn't even have the option of like now all everything. Like trying to figure out the right here. Where is it? Oh no, about like the math, like what, how do you know which math to do? Oh, same page. Because all of you know is that the office, and it says that they're showing up an error we can't because of my yeah. We have 3 people. Overall, it was a pretty bad day. The professor was like that, but it was just one of the
Okay. Is this still not working for you guys?
It's not on Excel 2011 on Mac.
You have to download it.
You have to like download it and everything.
Okay. Why don't we put that on hiatus for a moment? Let me finish just showing you what we would do,
Okay.
and then we'll figure out how to get that little addition into your system. But there are other ways to do this if you know how to use SPSS or whatever. I just want to show you how we would do it very simply in here, and then we can sort out these other details as we move along, okay? So what you would do is basically, I'd come to data analysis when you are able to add it in. And let's just assume that you can. We're going to do a t-test assuming equal variance.
Oh, I figured it out.
Oh, you did?
Yeah, you go to manage on the bottom, and then you have to check it, and then it pops up.
Okay. Cool. So let's come back and we'll visit that in just a second. You can show people. So I'll do a t-test for 2 samples for means. Very simply. I hit OK. So it gives me a little option here. And the first thing it wants to ask me to do is you want to pick the first range, which is going to be everything here. And then it's going to ask me to pick the second range, which is going to be everything here. Okay? Then it's going to ask me where do I want to output my results. So I'm going to hit this button. And you got to make sure after you hit this button, there's a weird little goofy thing it does where it sends you back here. You want to make sure that before you type anything in, that you click inside this field. So you can just watch me do it, and I'll show you what I mean. So variable 1 might be old 5. And I click in variable 2. Hit old 4. Now, remember I said click this little button here for output range. And now I want to make sure that I click in this open field down here. And what it's asking you is basically where do you want it to spit out the data results. And I'm going to put it somewhere over here where there's this open, empty field. So I might as well just click this button for now. That works. Click that. Notice that it puts this cell in row 4, in column F, F4. Okay? And all you do is then you just hit OK. And so, if we make these fields a little wider, it tells us some information. So first of all, it tells us that what we just did was create a t-test for the means of 2 samples. Variable 1 was basically old 5 collection. Variable 2 was old 4 familiar. Okay. See how that works? So it gives us this 2 pieces of information. Now it tells us the mean, the variance. It tells us our sample size, which is how many observations, and we had 10. So it tells us the mean for this. It says 3.3652. So the mean of old 5s, is that the same as we got here? Yeah, 3.625. So this average that we calculated is the same as this average. So we've got some nice internal validity here. Okay? It gives us our degrees of freedom, which is our sample size minus 1, so that's 9. It tells us our t-statistic, which is 0.5762. And then it tells us our p-values. Now I'm going to expand this out a little bit here so that we can read it in a little bit more detail. Okay, so we have our t-statistic there. Okay, we have how many observations. We also have our averages. And now, we usually want to do a two-tailed t-test, right? And so, this is what it shows us here. Our p-value for a two-tailed t-test, basically p equals 0.57. Unfortunately, it's not 0.057, because even that wouldn't be quite enough. So, it tells us that it's not quite statistically significant in this particular situation. Which is perfectly fine. The data is what it is. It doesn't have to be significant. It's not going to change your grades. Science is science. Science is just the pursuit of truth. And if the truth is that the conditions don't happen to differ, that's great knowledge. That's great information. That's a new discovery.
So you can end up writing papers like, well, it didn't prove, like I had my hypothesis, but the data didn't support that.
Yeah,
Okay.
it's perfectly fine. The data didn't support Christopher Columbus's hypothesis either.
Because I was just gonna say
He thought he was going to India.
didn't want to didn't want to fail because well your hypothesis.
You don't pass or fail in science based on if your hypothesis was confirmed or if it was right or wrong. So the beauty of science is that it's a process. It's a process for pursuing truth and trying to understand the truth of possible situations. What that truth is doesn't determine good or badness. Truth is just truth. If things don't differ, they don't differ. What if, okay, so this is a really good question. Can somebody think of an example where, so the suggestion from Kelsey had been the concern that maybe we would get in trouble or not get a good grade, or there would not be allowed to write something about a discovery that 2 conditions did not differ. Somebody think of an example where that would be not only perfectly fine, but in fact preferable. In which case that would be a good discovery to report, that things don't differ. Just a random, crazy idea of an example.
Maybe find like that familiarity, ERPs belong someplace.
How about something more practical? Why would it be totally cool to publish that there's no significant differences between conditions?
Maybe, for example, between two different units of brain.
Okay, that's helpful. You want to know, it's useful to know that two brains don't differ. Yes. How about if some salesman is trying to sell you Air Jordans, and they're trying to get you to pay $200 for a pair of Air Jordans, and you're like, why should I buy those shoes? And they're like, well, they're Air Jordans. They'll make you play better basketball. They'll make you a better basketball player. And you're like, all right, prove it to me. And they line you up for free throw shots. Before you're wearing Air Jordans and after you're wearing Air Jordans. And you measure how many free throws you make wearing the Air Jordans and not wearing the Air Jordans. And you find out that the number of free throws that you make in basketball don't differ significantly depending on whether or not you're wearing $200 Air Jordan Nike shoes. That's a pretty important finding, don't you think? Because you can tell everybody else getting hosed for $200 by Nike not to waste their freaking money.
Just think like a bunch of selling like for people.
Yeah. So, or instead of free throws, maybe they say, well, it'll make you cooler if you have them. And you measure other people's psychometric responses of how cool they think that person is. And it turns out that doesn't differ either whether or not you're wearing Air Jordans or not. You're equally cool or uncool. You know what I'm saying?
It's like the atom never ruins everything in science.
Yeah, so the point is that it's perfectly fine to report a finding that doesn't, especially for this class, but really in science in general. Finding that things don't differ can be a very, very useful and important finding. It can save us money, save us effort, save us lots of things. So it's not a bad thing if you find that it's not statistically significant. Our job as scientists is merely to report it. We're the referees. We call it as we see it. We call it as we see it. We see that there's no differences. That's what we call it. That's our job. And really, and that's the deal. So that's how you would do that, and you would use this information that Excel gives you very, very easily in order to write your statistical sentences. Do you guys remember how to write up your stats? Right? T equals degrees of freedom, the t value, then your p value. All right, we'll get to that in a little bit later, but the idea is that's kind of all. I just want to show you how simple it is in that regard. And maybe now we can take the time to have Fitria enlighten us into what she discovered, into how to get the add-on into Excel for the data analysis package.
So you go back to options where you want
Options, let's see here. File,
options.
options,
You click add-in,
add-ins.
and then on the very bottom, under manage, you click hit go. No,
Oh, here.
yeah, just hit go, and then you.
Ah, that's what it was. Yep. That's what you want to do. Analysis packet to the left, and then hit OK. Yes.
For Macs, if you have the updated 2016 Outlook, it's under Tools. So
Ah.
Tools, and
Tools.
then very last it says Excel add-ins,
Excel add-ins.
and then you just hit Analysis Toolbar.
Analysis toolbar. So, does that work for everyone? No. Okay, let's try it. Next.
That's it.
I don't have 2016 Excel.
So if you go to Microsoft Office and register as a student, you can re-download the new version.
Well, let's see what we can do. Let's see what we can make.
Yeah, it's on
Because I downloaded this, that's what like the internet said to do,
the toolbar.
the Excel stat, and like this is the toolbar, but I don't know what any of it is.
Let's just take a look.
It says all the things you do with it.
Yeah, it's easier.
That's the another option.
So try that out. See if we can get this to work on, and we'll work on the Macs now too. See if there's anything else. Go to calculation. explore, we haven't explored it, but my suspicion is that once we get it, it'll be super easy. See if you can grab that one, and that one, these in output spots, and over here, see if it says the same thing. Good. Really some statistics.
How did you get that transcript?
Yeah.
And then Google Microsoft Office in the student.
What do you want to see? What do you want? Instead of using channel insurance, did you take notes on the site?
So we got it actually done.
Another install.
Okay, that's good.
Yeah.
Because I was like,
And now
You guys?
it won't look any different. It is look at anything. But yeah, for the Is anybody having trouble with that?
I'm just waiting for the new Microsoft to download. And then I'm going to do a sheet full thing. So hopefully it
Is
works.
anybody else having trouble with it? Is it working for you ladies? Okay, so
No, last year, right? First year, sir?
I had problems.
Yeah, because you did say operations function on two ERPs. Yeah, you just gotta process subjects.
Oh, yeah. Yeah, you know those.
See, I can't, I tried to like update my
And then we split it by how many hours you work, and I worked about 20 hours. Even if it was kind of a lower end, even like 50 cents an hour, I'll still just $14. I do if you don't do.
Usually for like the last 2 years.
A nice week is an hour. Because then you're like 27.
Love, did that work for you? Yeah?
Get the data now. Nice, but everything else
Okay, so for the next little bit of time then, why don't you work on your own and process enough individual subjects so you have, between 10 and 15 so that you can do a sample group grand average and then work on getting some sample statistical results from a group grand average. And what you're going to have to do, and what some of the errors are that some people are getting right now, is because they're not saving the ERP files for the individual subjects with the bin operations having been applied to them. So after you run bin operations for every subject, you want to save that, and it's helpful to underscore it and add a suffix that says bin op or bin operation so that you know that you did it in that file. And then you grab that list of files for your 10 or 15 people and create a grand average of that. And then you'll be able to get some of these difference waves of these other conditions. And so let's use some time that we have in class now so you can practice continuing to do that, process your individual subjects so that you have enough to run a group analysis. And so then you can practice what we just did, which is to create a grand average ERP. We can plot those ERPs. And you can even filter them if you want, but really practice extracting that statistical information from bins that you have an interest in for some hypotheses, during time points that you have some interest in and a hypothesis, and practice seeing if you can get a statistical effect. And use this time to practice so that you have some experience under your belt, so you can go home and practice some more without me being there to help. Use me now to help you, and have some abilities to work with some data, because you might be given some sample files during the test that might ask you for a multiple choice answer of what the statistical difference is between some conditions and some subjects that I already know the answer to. And the only way to get the answer correct is to be able to do all the steps correctly, which means just create a grand average, extract the statistical information from the bins during the times that are mentioned, and be able to find out, say, what the t-value is or what the p-value is. And if you do the steps right, you'll get the answer right. But that's a target that we're going to have to shoot for. So knowing that, now you can practice and ask me at the places where it goofs up, where it messes up, and the places that I can help you now, because I'm not going to be able to help you with that stuff on the test. And so you can build towards that. We know that on Wednesday you need to be able to do it on your own. So tonight and tomorrow, you should be able to practice doing it on your own and troubleshooting on your own if it doesn't work. And so today we can practice doing it when I'm here to help you when you're not on your own. Does that sound like a pretty reasonable stepwise progression? Okay, let's see how that works. And if something comes up and it's really not working, we can amend that plan. And we can change it. But let's give it a shot. Okay? So kind of work on your own. I'm here to help. Raise your hand if you need me. And we can work on that. Yes.
So
your feet over here. Oh, your feet side. Oh, you have biceptic, right? So triceptic before. Over here? Yes, over here. I did that too. Oh, there we go. This will work for you.
For this, like I did the one you sort of typed in, and it said the selection line on column.
Then redo it.
Take a closer look.
Just click it right there. Oh, you didn't do it for once. You would have to just find your 21 artifact perception file and read it.
Well, that's it as in the key.
Like, I don't think it would. See, it's a problem. So go back. All of them, do they all look like that? It's an experiment. You know, go back. Go back to another room. So, you have none of them, so don't.
Yeah, it's something else.
Oh, outlook. That's good.
When I get back, to my, yeah.